So HDR FX Pro, who knows about HDR photography? Is that a known term? Or should I? Okay. Maybe a quick explanation. When you shoot pictures, a limitation in shooting pictures is often the dynamic resolution of a sensor. So shooting from a dark room like this one here, outside, would end up with either two pictures. One could be you have the light exposed outside, and everything in here would be black. Or you have the well exposed inside, but then the outside would be white, because the sensor can only capture so much of dynamic resolution. So what you do is you're shooting two pictures in the end, oversimplified. Shoot inside, shoot outside, and then you merge both. This is kind of what HDR does. It brings those two exposures that you have into one picture that looks like what you see right now here, because our eyes are adopting frequently. We look inside the room, we see everything. We look outside, we see everything. So we have a different perception of dynamic range, as our visual system is capable of doing that. And what we want to do with HDR photography is we want to bring that visual perception to photography. So what you do is you shoot multiple pictures. You shoot multiple pictures like those three here. So this here is the more well-exposed picture. This is overexposed. This is underexposed, and you merge them into one picture where you have full control over your dynamic range. So I start HDR FX Pro here from aperture, and the resolution is not friendly to me, because usually I have up here the CPU monitor. I didn't test that. That's the main thing with high-resolution pictures. But what you would have seen is that there are 4 cores in this machine, and all 4 cores are actually used to 100%, which means we scale quite well with that software. So what you see now is, out of those 3 pictures, there was 1 picture created, and the typical use that we have with our software is, on the left-hand side, we provide kind of presets that give you an idea of what's possible with the software. And I guess it's a little bit challenging to see on the projector here. Probably something that we can see on the projector well also. The different styles that are available. The challenge with HDR is that, it's not really a challenge, it's an opportunity. You have 2 aspects. You have a very creative aspect, so you can create pictures that are unnatural, like that one here, that doesn't have any natural look. Or you can use it really in the sense of fixing your lighting situation, or your exposure situation, and create a more natural look. So photographers use it in both ways, and we support both use cases. You can either create realistic HDR pictures, or you can create creative HDR pictures, and you can choose the style you want. And those left-hand side presets are kind of giving you a starting point, and then you can start manipulating the picture itself with different parameters. One, of course, is exposure, so you can go through the different exposures that you would have had with your camera. And you see when I change here the slider that there is a little bit of flickering. So you see the tiles updating, but you also see that most of them are using at the same time. It's another indication of the cores. The more cores I would have, the less of the tiling I would see. And this here is an i7 with 2 physical cores, 4 logical cores. So there's still some tiling visible. But the beauty of the multi-threading environment is that you really have a quick update, which is important to the photographer. So another thing that I want to show you is that viewpoint technology that we have, and that is highly relevant to Multicore, because it is a technology that is very interactive. So we have something that we call control points. You can drop it on a picture, and that control point automatically identifies an area in the picture. So what we can do now is we can change the exposure of the sky as we have selected the sky, and can selectively change the appearance of the sky as we want. Can you see that? Yeah. Can selectively now change the sky. This is what we call viewpoint technology. So you click on an object, the software identifies that object, and then you can change the appearance of that object with multiple parameters. And HDR FX Pro, it's related to the parameters that we have in the software, but with other products like Rebase, you get control over light and color. Here you have control over exposure, structure, your whites, your blacks, and can change the method strength, which I guess was probably a little bit too much of detail. But you have full control over your picture and can locally edit different objects. So I could also go and change the building and could increase structure, and I don't know, is it visible? Yeah. And you see that the building changes, and I can manipulate that selectively also with the very same technology. So you have a very easy and direct access. And the relationship to Multicore is here that we want to have people judging the quality of their result based on the direct interaction with the product. If that would take 10 seconds to render, it would not be usable. You need to see what's happening. It's a technology that needs to give you direct feedback. It needs to be a responsive technology, and therefore the multi-core optimizations are very important to us, and I think very important to our customers. All right. So let's go back to the presentation. So that was the product demo. So a quick summary of HDR FX Pro. It is a full-featured HDR solution. So we have all features that are required for HDR in the product. As all our plugins, it's compatible with Photoshop, Aperture, Lightroom. You can even use it as a standalone. So HDR FX Pro doesn't require necessarily a host. It's also usable without a host. It features our viewpoint technology, and it is a very powerful tool, in particular in HDR FX Pro, because it gives you local control over your image and your exposure. It is fully multi-core optimized. It is optimized for Sandy Bridge, which now is second generation of Core I think. It uses AVX, and it's well recognized in the market, so it's a well-established product. Which we received several awards for, and we have a lot of positive feedback from our customers, which is great to have. So what do we use to optimize HDR FX Pro? We're having in use right now from the Parallel XE product, the Composer XE, the Region Amplifier XE, and we also use the Intel Architecture Code Analyzer where necessary. We have the Composer in use in our current build environment, which is Visual Studio 2008, which is great that there exists support, because if you want to have AVX support otherwise in Developer Studio, you have to update to 2010, which is a decent investment, and you don't want to necessarily time it based on these things. Also, people need to get trained. So we're happy that we could use it in 2008. It really limited our investment into the AVX optimization. It links with the Visual Studio 2008 libraries, so again, not switching the development environment is a good thing for us. But we also have seen that we had to recompile all our code base, the full framework, the core framework, as well as the product code. We have seen that within the 350,000 lines of code that we have, there were only very minimal changes required, so it's about a dozen that we did. Not worth to mention, I would say. And that means the code that we have compiles usually on GCC and the Microsoft compiler. So in both with both code having the code compatible to those two, the Intel compiler didn't have any issues with that. And of course, the big feature of Composer 2011 is the AVX intrinsics and auto vectorization feature that is in there. Another important tool in yes.
What did you use to parallelize the application?
To parallelize the application, we used thread check. So as I said before, the parallelization happens in the core framework, which is an optimization task. We started. Yeah?
But yeah, that's the tool to check. But did you use OpenMP, TBD?
No, sorry, POSIX threads. So it's all platform. So we use the platform APIs for threading. Low level, yes.
Did you consider API as well? Because this tiling is optimized for MPI.
By the time we did it, it was not really available to us. As I said, the optimization for that started like 4 years ago. And I mean, today it's a different world. It would have been a lot easier, I guess, to do it from today's perspective. We invested a lot into our own threading system. And usually when I listen to what James says, I'm often like, ooh, we're a little bit too early, I guess. So we have been ready to use TBD. And we're still observing that, we're looking at it. We may make use of it in the future. Right now, what we have works for us pretty well. And it will be an investment without much of an additional gain. But we definitely see those things very positively. And we're observing them. And, yeah. I guess we have been a little bit early.
Could I ask, do you know how much of a speed up you've seen from AVX?
Yeah, I'll come to that a little bit later. But I have a little bit more info on that. Actually, it's the next slide. So another important tool, in particular, when you want to optimize, and as I said before, we're doing optimization in intrinsics. You want to know what you need to optimize. So you don't want to optimize the entire filter graph. You want to optimize where it really matters. Here a screenshot of amplifier before the AVX optimization and after AVX optimization. What you see here, oops. This first function we need to ignore. That is our pain function. So there is nothing we can do about it. It's mostly transferring data to the graphics card. But those next 3 functions we see are the ones that cost the most. So we focused our optimizations on those 3. And you see with AVX we got for the total brightness change portion of it, we can get down from 6.7 seconds down to 2.2, which is a decent improvement. The cross-scale step also brought a decent improvement, not as a great factor as the function before, but we're from 5.7 down to 3.8. And then the last function we optimized here, we got from 2.1 down to, I think, 0.9 or something. So they're decent speed-ups we could accomplish. Amplifiers for us the tool to identify those volumes. Yeah?
What are the green parts and tan parts?
The green part?
Yeah, the green part. I not read the label.
Yeah. So this is the threading indication. So an amplifier gives you kind of a feedback on how well are you optimized, and that gives you a hint on where you should optimize. This is a really high level display. Green means you're well optimized. Yellow means you may want to look at it. Red means there should be more. And in this case here again, you see the handle pane function. It's something where we transfer data from the CPU to the GPU to display it, and that's a process you cannot multi-thread, and therefore amplifier says, hey, don't you want to do a multi-thread optimization on it? And yeah, we would love to, but this will.
So if I understand you right, what you did is look at the total time and say this is taking too long, and then you looked at your algorithm and modified it, because judging from the DQ screen, it's well optimized. There's no real problem except the little bit of pen part.
Right, exactly.
So VTune is telling you it's okay, but you're telling yourself, no, it's not okay because it's taking too long.
Right. I think that's these are the two perspectives: data parallelism versus multi-threading. So the indicator here is more multi-threading indicator, while with data parallelism, you still can bring the total computation time down. So we were looking in this case only on the computation time to identify the functions that take the most to render and then to optimize. Hotspots, exactly. And we're quite happy with the results. I mean that was a decent speed up that we could accomplish. So as I said before, we like to work with Intel, and we worked with them for a while, and we used VQM before, and we were not big fans of it necessarily because it was a product that was hard to use. You had to learn a lot. You really had to get deep into it. It was efficient; it gave you all the data that you wanted to, but for an engineer, it was hard to learn it in the end. As soon as you understood it, great tool, but learning it was a tough thing. So I think maybe that's feedback brought us into the beta program. I don't know. We always have been honest, we had people from Intel coming to our office, showed us the new product. We were excited right away and started using it even in the beta. We were easily convinced. The ease of use spoke for itself and made it a really efficient tool. What we had before were I would say 4 people in our team took the effort to learn VQ and knew about it and helped with optimization tasks. So they used thread checker, they used the profiler, and were knowledgeable enough about the product to use it, but it didn't get broad adoption in the team. With the Kernel Studio XE, we have today more than 10 engineers using this on a regular basis. So this totally changed with the release of the XE edition. Of the 2011, with the 2011 version, that totally changed. So people look a lot more at hotspots. It's a lot more approachable. It's something that people want to use. They understand. It's not a huge burden to learn it. We even had the weird situation that in the past our Mac engineers used the Mac tools, and everyone looked at them like, oh, those are cool, love them, would be great to have something similar on Windows. We lately had those occurrences where people came to the PC guys and said, this Intel tool, we need a Mac version for that, don't we? That's pretty cool. I want to use that more than probably the Mac tools, which in case there is a possibility to do a Mac version, please Intel. And we used that opportunity to bring that wish from the team. So the engineer who did the AVX performance, Daniel, he was the one who used it a lot, really dig deep into it and used it for our AVX optimization product. He said it gives precise and down to the metal control while having a good UI. So this is kind of a balance, I think, that engineers are looking for. Give me easy access to it. Give me something that I can understand right away. And if I need to understand more, then let me dig into it. But give me that process. Give me a top-level overview. Let me identify hotspots. As soon as I have kind of the broader picture, then I'm willing to go deeper into it. And I think that's kind of the change that happened with VTune amplifier. So what did we get with the AVX optimizations? You have seen the amplifier interface, putting this into numbers. We have several routines optimized. Some are not optimized because they're simply not computational intensive enough. We have a filter like brightness correction, usually takes up 37% of the time. Speed of 3.2, cross scale 41. We only achieved a 1.8 speed up. Map to display 1.6. The total speed up for rendering then was 1.65. So if you look at the pure calculation that's happening, we brought effectively 1.65. However, we communicate this to the customers a little bit differently because this is only pure computation. After that, we have to bring it to the display. There's a static overhead that kind of reduces the factor a little bit. So if we look at the overall optimization success for HDR FX Pro, you see down the bottom, also it's like a 1.3, 1.4 factor. Really depends on the graphics card. How long does it take to transfer data from the CPU to the GPU? Another thing that we observe, the Sandy Bridge being on the same die, great thing to see, and we look forward to see more of that in the future. But also the multi-core optimization brings a tremendous value. So if you combine all these optimizations, we really see a factor from 5.3 from single thread, not optimized, down to 100 seconds. That means a lot to photographers. That's something where they really can spend more time shooting, less time in editing. They can work more interactively with the application, and it's something that, in particular for our customers, makes a lot of sense to invest into that. Okay, so that was my little presentation. In case there are further questions, let me know. I'm around here. We're open to any conversations and appreciate the opportunity.
Thanks a lot.